great. Got things covered up. Good morning. So, so welcome to the first workshop on functional software architecture, functional programming in the large. So this was an experiment I thought we'd try for reasons that I'll explain. Should we close the door? And I'm happy you're all here. First of all, I'd like to thank Graham Hutton, who unfortunately can't be here, my co-chair, who's ready to try this experiment. If you ever have a chance to work with Graham, please take it. So he's just a pleasure to work with and super organized. And also, I had the pleasure to work with this programming committee. I see Stefan is here, Simon is here, a whole bunch of other folks. And I've been on many program committees over the years, and this has by far been the most pleasant experience, I can honestly say. All differences got resolved unbelievably efficiently. And I think we put together a pretty good program. To put this event, and once we had the program together, the talks that we wanted to accept, there was one free slot, and that is this one. So I just decided I was going to fill it with, so now you can leave at any time. I'll put it like this. So this talk has not gone through peer review. But it might, maybe I can give you some context for this event. So I work for Active Group, and we've been doing software project development with functional programming in Germany for, I guess, 13 or 14 years now. We also run the leading German language blog on functional programming. We really do it across the board of programming languages. And also, we run the Bob Developer Conference. If you were there in Berlin for ICFP 2019, you might remember that there was a special edition of that. The next one is on March 15th in 2024. And if you're in Berlin for that, that'd be cool. Anyway, a couple of years ago, we had we had a small business teaching. Or we would give occasional courses to our clients on functional programming, but this was like 3 or 4 iterations that we did per year, and we were looking to improve our marketing for this. And so this was all about functional programming at the time. That was of course the thing that we were doing. And in order to make what we were doing more visible, we joined an organization called the ISAQB, which is a nonprofit based in Germany dedicated to the teaching of software architecture in general. And they have a whole collection of curricula on software architecture. I think there's 16 or 17. And we decided to submit another one on functional software architecture. This was a purely marketing idea at the time. And when we started working on it, we found out that, well, it sounded good at the time, but it occurred to us then that functional software architecture wasn't really a thing, right? If you kind of think about what has been published on how to do like large projects using functional programming, this is all scattered through our many ICFP papers, little aspects of it. Most books on functional programming are intro books, or they're kind of research books, but very little on how to actually do real industrial software projects in the large. And of course, that's what the software architecture community is concerned with. And so so we were thinking about that, and so the first thought we had to dedicate to what is software architecture and what is specific that we need to think about when we apply it, or when we try to apply functional programming to it. There's many definitions of this term, so I'm gonna say this, right? Software architecture is when you're dealing with large systems and long-lived systems. And of course, long-lived systems, I mean, they kind of have to be long-lived in order to become large. And surprisingly, many systems are long-lived, right? Even those that weren't intended to be that. And sort of the typical activities that software architecture is about. So first and foremost, most treatments on software architecture talk about splitting large pieces of software into building blocks somehow. And then there's a couple of sort of subordinate principles or activities. So you might think about as you're doing programming in the large, how to meet the requirements that come from somewhere in the domain. It might be about improving the system's qualities, and it's about facilitating change, and I'll get to that in a moment. Maybe you're like me, when I was reading this quality thing, I was thinking this is about making good software or bad software, but really in the context of software architecture, people usually use the term quality to refer to this thing, to an ISO standard, ISO 25010, which is about the qualities of a software system. And so this is just a taxonomy of properties that a software system might have. And so on the left, you have some things, probably hard to read here, functional suitability, so they're kind of the functional properties, but then there's things like maintainability, portability, security, performance comes to mind. So there's all kinds of other properties that your software system might have beside its functionality that we might impact using software architecture. And it's worthwhile, I think a lot of the time, so if you're doing professional projects, you're concerned a lot with the functional requirements, and this is typically what you get from the clients, and all the other things often get forgotten. So if you're doing requirements, or if you're involved with requirements analysis in a realistic project, it makes sense to use a taxonomy such as this one. It's not a particularly good one, but such as this one. There are other ones. And kind of use it as a checklist to talk about with your client, is this important to you, is this important to you, is this important to you, and then have that guide your development process. Now, unfortunately, there's this, right? Here's the same ISO 25010 qualities, listed in sort of, by the time that they become apparent in a typical development process. So my colleague in the ISAQB, Markus Harrer, did a survey among software architects and requirements people and asked them, when does typically, this quality come into focus in the development process? And as I mentioned, typically what's first is, the functional aspects of software development. And then as you go down the list, the things further down the line are the ones that are less visible when you actually use the system, right? In particular, I want to focus for reasons that might seem obvious, but that really require explanation. So maintainability is pretty far down the list, right? And so I think we all know that if you think about maintainability late, you might have issues, right? And so why is that, though? Has anybody ever read this book? Seen this book? So you can only find it so this is old. This is like from the 70s. But this is, I think, one of the original sources of the word coupling, if you've ever heard, right? And so, and it's highly recommended reading because these folks, the authors, Ed Jordan and Larry Constantine, worked in software projects at the time. And of course, all the things that we think we know about software development were not generally known back then. They were really trying these things out for the first time. And they found out two things that are notable. First of all, when you look at the cost of a software project, right, that cost is not primarily what you spend until you ship first, until your first release. Instead, the cost comes up later as you change your system after that first release. So really the cost of software is approximately, so one way to think about it is the cost of software is the cost of change and not the cost of writing it from scratch. Right, and so that's one thing. And then they looked at, what kinds of software systems are amenable to change and which ones are not, right? And they found out that the software systems that are amenable to change have something that we now call low coupling. So they have fewer, as opposed to many, interdependencies between the different building blocks of the software, right? And so I think this becomes understandable if you really put yourself in the mindset of if you forget everything that you know, it's not immediately obvious that splitting your software into building blocks is a really good idea, right? It might be that, and I've certainly met people, practitioners, who think, no, it's much better to put it all in one file and I can, I've got everything together and so on. So what they found out that no, so the cost of change rises as you have higher coupling between the system's building blocks, okay? So and this is why, and this means that sort of this coupling issue is at the center of a lot of software architectural activities. So, but even in the 70s, people were thinking about how can we do that? How can we have low coupling? And kind of the father of a lot of things, David Parnas, has written classic papers on what we now know as software architecture. And the classic paper says that, well, the way that you should structure your building blocks is that a building block hides a difficult decision that you made in the design process. And this way, you can change that decision, right, because it's hidden by the building blocks interface, and that would be good. Now, strangely enough, this was 1972. Now, if you listen, if you like go to a bookstore and buy books, modern books on software architecture, right? So here's two prominent software architects, or there's Simon Brown and Uwe Friedrichsen, right? And when you ask them what their definition of software architecture is, they say, well, it's about making expensive decisions. So at that point, there's something wrong, right? So we were, in the 70s, we were thinking that really we should make decisions so that they're cheap, right? This is what this is about, right? But somehow, the architecture community has resigned itself to the realization that, oh no, we got to make expensive decisions early in the process, right? And if we get them wrong, that's a problem. So a lot of software architecture, strangely enough, is about making sort of upfront decisions these days, right? And so you might think, well, you know, obviously, I mean, this is a world that's very, very different from sort of the way that I've grown up developing software, but I've been mostly at home in the functional community, which is really a almost completely disjoint community from that community. On the other hand, well, you know, so we've all been doing functional programming. Yes?
So I'm just trying to understand this idea of hiding the decisions.
Yeah.
So is it about putting you in a position where you can change your mind? So
Yes. Yeah.
Or is it about, okay, so it's not about delaying the decision as late as possible so you still have options?
I mean, I think I can use the same techniques to delay a lot of decisions, right? In practice. So anyway, so here, this is what we're thinking about, right? Design decisions. So anyway, so the paper, of course, goes into particular examples you know, that were relevant at the time. I think the simple way to think about this is, am I going to use like this database or that database? That tends to be an expensive decision, and I can tell you, in a software project, right? And so you build some kind of abstraction, some interface, right? And this kind of started the notion of having interfaces that would abstract over your database. But of course, what you can also do, I mean, once you're doing that, right? Once you're creating an interface to hide your database, if you're in practical software development, you know, having to hook up your system, even if you've made your decision and hidden that decision by your module, you've still made it, right? You've still made that decision. This introduces all kinds of practical problems in the development process if you really have to spin up your Oracle instance to do any testing of your software, right? And so you might even not make that decision yet at all, what database to use, and instead put in some kind of, RAM-based, couple of functions that pretend to be the database. So I think it's both of these things, right? So anyway, so question for you, really. So I'm gonna put the work back in workshop today a little bit. So what have we done for architecture as a community? So it's an honest question, right? I have a list. I'm not going to tell you that list, though. So in particular, when it comes to splitting systems into building blocks, anybody have any idea? So here's an empty slide. Here's an empty slide that I could put things on. I could put things on that slide. What should I put on that slide? What have we functional programmers contributed to the art of splitting a system into building blocks? What would that even look like, a contribution?
Abstract data.
Abstraction?
Abstract data types.
Abstract data types. Very good. Okay, what else?
I mean, the ML workshop is just text also, ML modules.
ML modules, a module system. So some mechanisms.
Modules in general.
Modules in general. Very good. Okay. So we've provided. There's a whole thing there, right? So we've provided like technological mechanisms that help with expressing, the splitting of your system into building blocks. Yes.
I think just abstraction in general.
Okay. Yeah.
I mean, it allows you to think of all the building blocks in
Yeah.
very
Okay.
ways.
Great. What else?
Polymorphism.
Polymorphism. Okay. The strongly typed programmer here.
Thinking about composition.
Composition. Okay. Great. It's a great list. It's coming along.
Purity.
Huh?
Purity.
Purity. Okay. Okay. Good. I'm just gonna.
So expressive type systems generally because you describe how you use a building block.
Yeah.
Have the compiler track that you get rid.
Yeah. Okay. Very good.
Separation of concerns.
That is, of course, a general term in software architecture. What have we contributed to that? Actually, I don't even know what that means. So.
I think I was thinking about how you might have a functional core, and then so you might have a pure part, and then you sort of push all the complicated bits into a smaller bit.
Okay, we'll get back to that, actually. So, okay, so great list. Which one of these things do you think has made it out of the functional programming community? Seriously?
Composition, that's not sure.
No? No? Tell you right now. So purity has made it out a little bit. We'll get to that. Yep, purity has made it out a little bit. Actually, that pure part versus the complicated bits, I'll get to that. So there's a shadow of that in the architecture community. I think that's it. That's it.
Inexpressive type system.
Yeah, so there you go. Anyway, so seriously, so I think we need to recognize that we have not made an impact, really significant impact on the architecture community, and that means also that is what feeds into the developers at large.
I think type systems, expressive type systems, is starting to penetrate into like out of that world. So we're seeing it with TypeScript being very popular, or even Go.
Okay. Okay, yeah, so maybe even then polymorphism along with that, right? But as I think what we're not seeing is, we're seeing how that is entering programming practice, right? What we're not seeing so much is sort of enter the thinking of the architects, right? And so, but I'll chalk it up as a win anyway. That we're, we got to grab onto whatever we have. Okay, so anyway, I might not I don't think I have to go back to the full screen mode on this. So facilitate meeting requirements. What have we done there?
Not sure if this facilitates or AppExpert and verified programs.
Program verification? Okay, yes. Now that's sure made it out. Property-based testing. Is that from the functional community? I don't think so. That is depressing, right? But actually, I have good news on that one. But I'm sorry. Priority-based, well, to some degree, yes, to a small degree, right? Program verification, not really, right? Most verification projects really already have like functional programmers or strong functional programming side to it, and it's very I'm trying right now to increase awareness, even that it exists outside of the functional community, and it is super hard, I can tell you.
It's not completely true. The people in everyday life, for example, the people that in avionics, they don't come from the functional community, and they do a lot of verification.
Okay. So maybe avionics might be an exception. Yeah. So I'll take that back. But these are very specific. These are very even within the architecture community. I can tell you that they're very isolated. It's a tiny niche, right? Anyway, but I have good news for you. So actually, there has been made an impact. I think a huge impact has been made by this book, How to Design Programs. So Matthias Felleisen's group, I think, started it started in the 90s to think about teaching programming as part of the intro course, and as a part of that, developed a methodology for turning problem statements into programs, into systematic data definitions and functions. And this is huge. I think it's still pretty far from reaching its potential. But this is certainly an important contribution. We're seeing, especially through the intro courses that are being taught in many places using that, we're slowly seeing that seep into the community at large. And and we're seeing actually some books here. So here's a book, Domain Modeling Made Functional, that does not come out of the functional community as such. But came out of the domain-driven design community applying functional programming. Also something else, combinator libraries, right? We kind of forgot about this one. which, here's 2001, and we can see the 2001, this was like folklore, right? Everybody was supposed to have known this in the functional community, and I think most of us know what it is. On the other hand, this is completely unknown out of the functional programming community, basically, combinators. Even though it could also be part of object-oriented programming, for example. There's no reason why it couldn't, but it isn't, right? Nobody knows about this. In part, I think, because there's very little documentation. We have lots of papers on saying, I made a combinator model for this, I made a combinator model for that, but very few on how they were built, what methods, what techniques were used in constructing them, right? If you think about it. So there's a fair amount. So here's my list, right? Design recipes, algebraic properties, so not far out from property-based testing, abstraction, combinator libraries, and from there also embedded DSLs. So these are things I think that are starting to make some inroads. So good morning. So next up, systematically improve the system's qualities. So as a reminder, here's the list of qualities. And this quality word plays like a prominent role in the way that architects talk about software that, to this day feels kind of alien to me. So here's a very popular book on software architecture by the SEI Institute at CMU. And they have this strange thing where it says, functionality does not determine architecture. And does that seem odd? So there you realize these people are doing something, I think, are in a different place than we are, right? So just to get you in the mind, so I think we've talked a little bit about sort of requirements. These things that we talked about were mostly about the functional requirements. But it does make sense to think about the other qualities a system might have in a more systematic manner. And what this community typically does is something called quality tactics. And so here's an excerpt from that same book where you go, well, if availability is among the requirements for your system, then here's a catalog of techniques that you might use in order to impact that particular quality, right? And so you can think of it like roughly like a patterns manual, even though the architecture people make like a big thing out of distinguishing this from patterns. What have we done? I actually have a list, I think.
Like affine types.
Affine types. Okay. Actually, so I have notes down here.
I'm still not quite sure what qualities we're talking about.
Pick any one, right? So they're hard to read. So there's performance efficiency, then there is compatibility, usability, reliability, security, maintainability, and portability.
Okay, hang on. What does non-reputation mean? It's under security, and I'm curious about the meaning of this.
Let's not worry about the details here so much, because we could talk all day about if that taxonomy makes any sense. So pick any one, right? Pick like performance efficiency, for example. Are there any functional techniques that we might bring to bear on a system's architecture in order to impact performance?
User space scheduling. User space scheduling.
User space scheduling. Is that a functional thing?
Like Halo. It came out of the PL research.
Okay. Okay.
Writing it to not have bugs in the first place.
Huh?
Writing it to not have bugs in the first place.
Yeah.
An idea that only functional programmers have ever had.
Yeah. So, certainly, arguably, there have been this research field. If we're thinking about security, right, there have been various works on type systems for various aspects of security, right? So maybe type systems for security would be one thing.
I would argue that the new maintenance is easier as well.
Huh?
The experience of refactoring with strong text systems versus not.
refactoring type systems. Okay. I mean, generally, having equational reasoning for optimization, right, is something that we've been doing, right? Equational reasoning. Right, that's certainly something. Let's see, I have a list here. So here I was going to say that the module systems actually help with something that in this taxonomy is called portability. So they're just going to show up here again. And let's see, what else do I have? And generally we have things, I'm just going to put like a couple of dots here. I think we all, I think even we underestimate, at the beginning I said maintainability is something that is closely correlated with coupling, right? And I think even this community underestimates what effect purity has on coupling. And what the big difference is between the software architecture community at large. So maybe I'm just going to say purity now, but other aspects, of course, might impact that as well. So I think the elephant in the room really is, what have we done for facilitating change? Somebody already mentioned type systems for refactoring, right? Or static types for refactoring. Okay. I'm not. I would argue, though, right, that sure we can think of cases where the types have made change harder, right?
Some types and exhaustive hierarchy, basically.
Yeah. Oh, definitely true. So as I was going to start with purity or immutable data, right? That would be one thing. And of course, again, sort of the functional module systems, like the one in the ML dialects, contributes to facilitating change. Anything else?
Gradual typing is important to have there.
Okay.
Long before TypeScript.
Still, I'm just going to say, for the record, I'm still on the fence of that one, I think. So not sure about that. Anyway. So, but again, if you look at all of those lists and think, how many of these specifically functional things have made it out and are common practice in the software architecture community outside of functional programming, there's very little. For example, basically there aren't any module systems, right? There's no module, in use, right, in software projects. There's no module system in Java, for example, in the sense that we think about module system in ML, for example, right, or even in Haskell, right? There just isn't. Which means that sort of the whole modules discussion moves to the level of objects and their interfaces, which is awkward in many ways. Anyway, so. But they don't get used as such, I can tell you. I think we might, but you're right. They've made it into Java. They have not made it into programming practice yet. So what we will probably see, they just arrived, so we'll probably see that happen. So that's good. Anyway, so making sure that we're finishing on time. So I think there's a couple of challenges, and I'm just going to give you, I think, about two challenges. One of them might be to think more about sort of functional macroarchitecture. What does that mean? Well, for example, the architecture community has come up with macroarchitectural patterns, organizational patterns for a software system as a whole. And the one that's most popular right now is something called hexagonal architecture. Show of hands, who's heard of that? Wow, nobody. So for the record, if you're watching at home, nobody raised their hands. So the good thing about hexagonal architecture, forget about the hexagon. It could be a circle or 8 corners. It doesn't matter. So the idea is very simple, that you put your domain logic in the middle of the system, and they talk about it, and the idea is that you express your domain logic free of technology. So you don't introduce like the big frameworks that are common, like Spring or whatever, into the central realm of the application logic. And you move all interaction with the outside world to the fringes of the system, and you make sure that all outside interaction goes through interfaces, and I can replace the implementation of those interfaces specifically for testing purposes. So it's not a complicated idea, and it works extremely well in practice. People start their project because they can set up like a project template based on this. That makes it fairly easy to find your way around a project if you use this hexagonal architecture. Now, if the hexagon doesn't matter, you might think, well, wait a minute. I've seen something like this in the functional context, which is this pattern, right? And now this talks more about the technical side of things, right? That the pure stuff, right? This is not talking about the domain, that the pure stuff will live in the middle and that your I/O monad is going to be at the edges of the system. But you can easily think about using this pattern at the typical facilities available in functional programming to implement the hexagonal architecture, right? And maybe you're not going to use objects and their interfaces to represent the interaction with the outside world. Instead, you might use effects, for example. So we found effects to be fairly effective there. But once again, I mean, one problem with this pattern is really that it only talks about the technical side, whereas software architects tend to think about the domain, right? And so there's a disconnect there. There's a mismatch. I mean, it might be particularly useful to also think a little bit about what's going on the inside here, because if you look at the architecture community, here's a recent blog post, and you can see here, well, a monolith means just a deployment monolith, right? It's something that you link together into one binary and you ship it, right? And you can see here, apparently in 2022, we still need to talk about modular architecture for monoliths. And down here, well, you can't see it. Well, if you look, no, you can't see it. Let's see if we can see it here. It's just outside. If you look down here, you can see that they've introduced a new term for modular monoliths called the modulith, meaning representing a very common consensus in the architecture community that your monolith is always unmodular, right? And that's kind of depressing, and it seems that we should be able to make a contribution there. So that's one thing, right, is that we could help the architecture community to build modular monoliths, maybe even like by default or something like that. So that would be one challenge. Another one would be to combine functional architecture with something called domain-driven design. So show of hands, who's heard of domain-driven design? Oh, at least about half the hands have gone up, so that's good. So for the rest of us, domain-driven design was started by this book, now I think having its 20th anniversary this year. By Eric Evans, which is about tackling complexity in software. And again, this is one of those books. You read it; it's very alien territory for functional programmers, and it takes a while. I mean, I'm still adjusting to sort of this way of thinking. But one way it does is so there's various parts of it. But one important part about it is that you split a system into sort of large building blocks, so that the individual building blocks can be worked on by separate teams. Okay, so I mean, when we're talking about for functional programming in the large really eventually means you have too many people, and you have to split them up into teams for various reasons. And then the question is, well, how do you do that in such a way that your development process works, right? And the reason for that is something called Conway's Law. Who's heard of that? Okay, about, again, half the people in the room, again, very familiar to software architects. So this goes back to a paper by somebody, not the Game of Life Conway, somebody called Mel Conway, who thinks about organization and organizational structure. And he said, well, any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. In other words, if you have 4 people and they work on a compiler, you'll get a 4-pass compiler. That's so the programming language version that I'm sure you've heard, right? And it's very difficult to work against that. I don't recommend it, right? So really what you try to go with it. And so one of the central insights or one of the central ideas of domain-driven design is something called a bounded context. So the idea is that you split your system ruthlessly into parts, and each part can be worked on by a separate team. And then it might be that as you split your system, they might have things in common. So for example, if you split your typical e-commerce system, each subsystem might have its own, might need access to customer data, right? And the idea in the central idea in domain-driven design is you don't have a central data model for those things, even though those entities occur in several different bounded contexts. Instead, you allow the team working on each bounded context to develop their own models, right? And maybe you need to somehow correlate them, then you stick an ID in there, but really everybody does their own model. And that's a radical, I don't think I can convey how radical that idea is. And how effective it is in practice. So we have different models, the customer, which is also very different to sort of classical IT, where you have like a big relational database that has like the one customer table in the middle. So instead, everybody does their own, right? And sort of the logical continuation of this idea is an architectural pattern called self-contained systems, where, I'm sorry? Yeah?
How do you find some mismatch?
You don't.
Well, then you get lots of bugs.
Surprisingly, no. Not really. I mean, there are problems with this. I'll get to that in a minute, right? But you really, one way, a friend of mine who's who's headed a lot of groups doing this kind of architecture, he expressed it this way. He said, our programmers tend to be nerds that don't like talking to each other, so we're optimizing for that case, right? And the reason for that you're doing that, and this is maybe counterintuitive, so there have been studies on software quality in the sense of quality good or bad, and they found out, among other things, that high software quality correlates with a high release frequency. There you go. Not with lots of approval processes and code reviews and proofs, I don't know, that kind of thing. So the more signatures are required for release, the worse the software gets, right? And so what this does is it enables each team to release independently and therefore to have overall releases much more frequently. So the question of having does it create more or fewer bugs is kind of not the right question, because you have to have the trade-off not just between how fast do you create bugs, but also how fast can you ship fixes, right? And so it's a little bit more involved in that. Anyway, with self-contained systems, so that's that really is the extreme continuation of that idea. You only have each group, so each separate system maintains their own front end, their own business logic, and their own database, and their own DevOps. And the only communication between these subsystems happens via asynchronous feeds. So if somebody needs a customer database, they got to create their own, right? And if the customer data comes up in some other system, then you learn about it by just subscribing to that asynchronous feed and moving that into your own database. So again, in this talk, I can't really convey how extreme this idea is. So on the other hand, so domain-driven design, they've adopted functional programming, but it's a very different kind of functional programming than the one that we're used to. Specifically because that group does not do abstraction, right? I don't really have time to go into that, so it just looks different. So really the part of domain-driven design that's called tactical design is something completely different from the way that we do domain modeling and functional programming. It's evolved independently. It's got its own techniques. It's very different. And so really there's a lot of work to be done, but I think this field would benefit a lot from functional modeling. To create what I call deep domain models, which is typically what combinator models create, right? Is they create insights that weren't evident in the domain before. Also, one problem that these architectures have is, well, it's all well and good, you create this division into bounded context. You create this upfront because you have to assign your teams. And this is all fine, but all projects that I've talked to that do this end up with a situation where that boundary is in almost but not quite the right place. And then remember that all monoliths are unmodular. They don't know how to move the boundary, right? And that creates all kinds of problems. And so it seems like a very primitive, banal problem, prosaic problem. But if we could help that community move their boundaries, that would help. So I think we should think about functional macroarchitectural patterns. We should popularize functional programming for architecture. We should truly integrate functional programming and domain-driven design, which is all the rage right now. So I'm wearing, I think, a T-shirt from last Domain-Driven Design Europe conference, and let me tell you, that conference is a lot bigger than this one. And that's just the European version, right? And write things up, and I guess some of you have done that for the proceedings, so thank you for that. There'll be more opportunities to write things up because there's an upcoming new category at JFP on functional software architecture. So if you deal with large-scale software in any way, or you think about it, right? Even if the thing that you did a couple of years ago could be framed into, how to do programming in the large. Please think about writing it up and submitting it to JFP. And who knows, maybe we'll do another one of these workshops next year. That's it.
Thank you, Mike, for this very interesting talk. I have to look. There are actually currently no question from remote participants. If you have one, please write it on Discord. Well, are there any other questions here in the room? Yeah.
Could you take the mic so that the remote participants?
So something that I've observed from working in a sort of fairly large company, architecture-wise, is that an alternative to domain-driven design is a way where teams are empowered to make change across a large code base, even in parts of the code base where they don't own the code. And that works by having a very efficient code review system where you put up your change and then you can iterate on it with feedback from the people who are more familiar with the parts of the code that you're not directly involved with. I don't know, I wonder if you can comment on how that relates to domain-driven design. Is it different, or is it?
I think it's different. I've certainly seen organizations that succeed with this kind of model as well, somewhat to my surprise. I have to admit. So I mean, it's certainly not the only game in town. I don't think the DED people claim that it is, right? It's just one architect. So I wonder, though, that how much sort of organizational discipline is required to make sure that people don't destroy somebody else's code base. So how much culture? How much of that is culture, right?
A lot of automation helps.
Right. Okay. Yeah.
Lots of CI, lots of automated testing.
This, of course, helps with domain-driven design. Frequent releases as well, right? I should note, though, that maybe what you're describing, one advantage of that is presumably you really have a lot of testing that happens before releases still. And you have that in domain-driven design too, but with this kind of self-contained systems architecture, because the other teams release independently from yours, right? Some testing inevitably happens in production, right? And you kind of accept that, and you optimize for being able to fix your mistakes fast. Right? That makes any sense. Yep. So thanks. Yeah, good point.
More questions?
So you talked a lot about writing things up and sharing them, and you also talked about the way that signatures hamper releases, and that actually hampers software quality.
So we're not talking about type signatures, right?
Right. Approvals. We'll use that word. And I come from a highly regulated industry, and so there's a lot of tension between making sure that we're meeting the regulations we need to meet, but also being able to be more agile, be more technological, ship faster. And I want to highlight that I think what you've identified is that the problems here are as much social as they are technical, and there's not going to be a technical solution for a social problem. And so I wonder if you would comment any on that tension or how you see that progressing.
So definitely very relevant in that also the domain-driven design community sort of thinks about software from the social side rather than us functional programmers who tend to think from the technical side, right? And there's, similar to sort of types, static types or no typing, there's proponents, no, absolutely, the technical thing is completely unimportant, and vice versa, right? The choices that are made, in the social context are impacted by what is technologically and technically available to you, right? And so I don't think there's any way to separate those things. And in the highly regulated industries that I've worked in, yes, they were highly regulated. Yes, there were approval processes. No, these were not conducive to high quality. So I sometimes wish the social parts of these organizations would think about how to work with the regulatory processes in order to honestly think about achieving high quality rather than just making the process happy. If that makes any sense. Yeah, one more, and then we probably need to move on.
What is the largest project that you have worked on and designed?
I mean, I try not to design the whole project, right? So generally, I think the largest one that we've worked on is for a large retail chain in Germany. We've worked on their self-contained systems e-commerce system. So, and that had, I think, 5 or 6 teams with maybe 6 to 10 people each. Yeah. So
50 persons.
Yeah.
Developers.
Yeah, developers,
Or
and then you're also your
QAs.
product owners and so on. Probably in total about 100 people.
Great.
Yeah, so Simon's worked for larger, but still large enough. All right. So then let's move on to the next talk.